All right, guys, welcome back to Burt's Basics. So today we're tackling thrombocytes. And if you remember, thrombo was the medical word to clot. So today we're going to talk about how we clot. And remember, thrombocytes are not real cells, they're fragments, so we're going to call them formed elements. So it says here, thrombocytes, they function in clotting. That's what we're going to focus about. They're fragments of cells, so they're not really part of a cell. So since they're fragments, they don't actually live very long, so we make them all the time. So now let's talk about how we clot. Okay, have fun with this one. Now, hemostasis is the process of clotting. Please don't get this confused with homeostasis. Homeostasis is a different word, okay? Homeostasis, let's finish my O there. Oh, now it looks like homeostasis. Well, don't confuse it with that word either, okay? Homeostasis is the way of keeping my body in a stable state or condition. Hemostasis is the process of clotting. So, okay, let's draw. Here is, wow, that's not very good. This is a blood vessel, okay? So here's a blood vessel. All of a sudden, someone throws, that's a sword. Is that a sword? Okay, you know what? I suck at drawing swords, so let's get rid of swords. You know what I'm good at drawing? How about we draw this? This is a atomic battle axe. Okay, someone throws a battle axe. X. Okay, I don't know if X has an E on the end. And it cuts my blood vessel. Chop! So now my blood vessel is broken. So now let's go ahead and explain how you're going to clot. So now here's my blood vessel. It's ruptured. Okay, you're bleeding. Let's say blood flow is going in this direction. So you guys have your red blood cells. You have your white blood cells. Okay, and you have your platelets. Cruising around in your plasma, just chilling. Okay, what is the first thing we need to do? Because I think it's actually surprising what the first thing is. Now, if you have your detailed notes in front of you, this should make sense. But everyone always thinks, well, the platelets are just going to plug the hole. That's a big hole. And my blood pressure is going quite high right now. So the first thing we actually have to do is we do something called vascular spasms. Now, when I think of spasms, I think of Charlie horse in my calf. And I know what vas is. Vas refers to vessels. So now let's go ahead and draw on the outside of this. You know that this is made of smooth muscle. Okay? You know you have smooth muscle on the outside of every artery and vein because you can't control it. It's time for the smooth muscle to work. So the smooth muscle tries to do two things. Number one, this is a big gap. Oh my goodness, that's a big gap. We're bleeding profusely. If there's any way I can close that gap to minimize bleeding, let's do it. Not only does it try to minimize the gap, it also reduces the flow of blood so that we have less blood to this area so we don't bleed out as fast. So the first step is vascular spasms. So let's go ahead and clean up our drawing just a little bit. Okay, and let's just make sure that we're comfortable with what we're doing. So we have our vascular spasms. So now let's talk about my hole. Okay, all of a sudden now this hole or this damaged blood vessel is a lot smaller than it was before. So now can I make it even smaller? Let's say the hole is to there now. Okay, and the smooth muscle did a good job. Not only did it do that, but it reduced blood flow here. Okay, so there's reduced blood flow here. So now that I've done vascular spasms and I've tried to minimize the damage area, now I'm ready for platelets to get in gear. So here's the money question today, because if you guys are paying attention at home, you'd be like, oh, this is easy. Just get the platelets and fill the gap, because they're clotting cells. Well, I get that, but how come platelets don't stick here? Or there? How come they can stick here? Do you understand? That's kind of an interesting question. To do this, you have to go back to tissues. Single layer, flat. I'll say it again. Single layer, flat. Single layer, flat. You should think simple squamous. Blood vessels are lined with a simple squamous layer called an endothelium. And guess what? Platelets don't stick to those. So what happens if platelets try to stick to those? They what? Bounce off. So guess what happened with this hole? You still have endothelium on this side, except for the spot where there is the damaged area. Okay, those are your simple squamous cells right there. So when a platelet adheres to something that is foreign, like a weird tissue that it's not familiar to, say like smooth muscle, then guess what? The platelet will adhere. As soon as the platelet adheres, it changes into this. It's just what they call an activated platelet that releases chemicals, okay? And those chemicals are like, hey guys, I found a problem. Come help me fill this gap, please. And they do. And they start filling this gap. Now step 2, shouldn't freak you out too bad. Step 2 is called a platelet plug. It's just a plug full of platelets, and it adheres to the open or to the damaged spot to try to heal it. So now let's go ahead and clean this up a little bit. Can I clean this up just a little bit? Okay. So now let's do bigger than this. Ready? So now let's go through my guy here. So now I have my blood vessel who's broken, right? I have now successfully adhered to a platelet plug. They activated, we call this platelet aggregation, and they get all these platelets here to the party, okay? But there's still another step, okay? The best example I have of this is if you've ever poured cement before, which I know is a weird example because probably not many of you have done it. But if I was going to pour me a basketball court or a driveway, and this is going to be my basketball court, I can go ahead and dump cement in there, but it wouldn't be very strong. The first thing that we do is we get some metal rods, and we put some metal rods in your rebar, okay? And those metal rods will give it superior strength. Those are called rebar. And then you pour the cement over the rebar, and that cement will be infinitely stronger because you support it with rebar. This is exactly the same thing. I want you guys to think of a platelet plug as weak. Okay, it is serving its purpose, but it's not super strong. So what I need to do is I need to get this platelet plug a super strength to make it stronger. And to do that, I need to add rebar to my plug. Lucky for me, floating around in the plasma, I have a lot of proteins. Remember how we talked about there's proteins floating around in your plasma? We talked about how there's antibodies in there and lots of other things. But the biggest thing that we have in this case is something called clotting factors. So what happens is clotting factors are going to act like rebar in the cement. So what happens is through a series of enzyme reactions, which there's a ton of them, and Weber you'll need to learn a lot more, all of a sudden I get these rebar, clotting factors, fibrin, okay? All these different guys in here to make it stronger. And then once I finally get all these rebars in here to make it super, super, super strong, we get to our last one, our last step, which is coagulation. When I can coagulate it. Now, we're going to talk about diseases in another video, but this is a perfect time to mention it. There are some people who can form a platelet plug really, 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 really good, but can never get to the coagulation part because they tend to be missing one or more clotting factors, which means they cannot really solidify that plug. And that is called hemophilia. So those are my 3 steps. So let's look at your notes again really quick. So it says here, when we talk about clotting, there's 3 stages. Hemostasis refers to the mechanism in which bleeding is stopped. So hemostasis, process of clotting. Okay, we do vascular spasms first. So just remember your picture. Vascular spasms, we try to take the hole and we try to make it smaller and reduce blood flow down. Okay, step 2, platelet plug. Once I got that down, I tried to form a plug. The plug is awesome, but it's not really strong enough until I can get to coagulation. Coagulation is where I'm going to add all these rebars in here to make it infinitely stronger. And those are your 3 steps of hemostasis. Okay, and there's notes on each one. So vascular spasms, smooth muscles start to contract. You guys can pause the video. I'm going to go through these fast. Platelet plugs. Then we got our platelet aggregation. Don't worry about that. Platelets have to stick first. Then they start to form a platelet plug through aggregation or releasing chemicals. Can you see these chemicals saying, hey, come to the party, guys. We need you. Okay. And then coagulation. Coagulation is where it forms what we call a significant clot, or forms a clot or a gel-like substance, okay, with protein fibers, which we will call clotting factors. Now, I have a couple pictures of here. That's a real clot. You can see that red blood cells are in here. And the last time I showed this in class, people were like, hey, wait, red blood cells, they don't aid in clotting. Well, they don't, but that doesn't mean they're not going to be in a clot. Remember, they're the majority of all cells. So that you got your platelet, you got your clot in there, and then here's our pathway. You do not need to know this for this class, but in Weber, you do. I just want to show you a couple things here. Calcium, 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 calcium. Is calcium needed for clotting? Without doubt. Now, extrinsic means I'm damaged from the outside. Intrinsic means I'm damaged from the inside. What I want to show you is I want to show you some Roman numerals. Do you see how there's Roman numeral 12? There's Roman numeral 2. There's Roman numeral 1. There's Roman numeral 8. All those Roman numerals are clotting factors. So you can see this kind of a big deal to try to get here. You know what prothrombinase is. ACE is an enzyme. ACE is an enzyme. Okay, so there's a series of enzymes that go through this reaction, and my goal is eventually I get down to a strengthened fibrin clot or a clotting pathway. Okay. Okay, last thing I gotta talk about. Can I do a picture instead? Okay, so what's really kind of crazy, and you'll learn this in Weber, if you take Weber, is once we start forming a clot, okay, we start dissolving almost immediately. Now, I know that sounds crazy because you're like, man, why would I destroy it when I just made it? Well, the biggest afraid you have is what if the clot gets too massive? Well, then it can impede blood flow from point A to point B. So as soon as we start making the blood clot, we actually start dissolving it and disintegrating it so it can stay in a manageable size, okay? So what happens is sometimes we have clots that we do not want, okay? So whenever we talk about this word right here, a thrombus, okay? Now, a thrombus is generally defined as an unwanted blood clot, okay? So that means a thrombi is a clot. Now, you could call this a thrombus, I guess, but generally when we talk about a thrombus, we're going to talk about a stationary is probably the best word, stationary clot. Now, if you guys actually look up a thrombus, it can be more than just a blood clot. Like, say it's a collection of fat or something that has a bunch of medications together. A thrombus is a solidified object that tends to be stationary, okay? Generally in a negative connotation. So let's say this is a thrombi, and it's a little bit bigger than we want it to be, okay? So it's a stationary thrombus. It's causing some problems, but then let's say a chunk of it, let's say it fissures right down that green line. Now there's a problem because now I have a traveling thrombus. Now this is different because remember, thrombus was stationary, so I need a different word for when it begins to move. And when it begins to move, that's when we call it an embolism. So an embolism is a traveling or moving clot of some sort, okay? And then we can talk about anatomy and where you think it's going to go. Most clots are formed in your legs just because of pressure-based systems. So most emboli come up through the inferior vena cava. And if you know your anatomy of the heart, it goes to the right side of the heart, which main goal is just to send it to the lungs to get it oxygenated. And in the lungs, it will encounter its first capillary network. Capillaries are super small tube. So then what are we going to call it if I get an emboli stuck in the lungs? Well, then we call it a pulmonary embolism, which are very, 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 very scary. Okay, guys, that is your, excuse me, that's your lesson on thrombus, embolist, and hemostasis. Now, I usually try to end the videos with questions. I'm not going to end with questions today because I got a YouTube video for you to watch instead right there. So do me a favor. I know it's cheesy. It's kind of dumb, but it does a pretty good job of showing you in an animation of what hemostasis looks like. So do me a favor, go ahead and open up this YouTube video right there and just kind of watch it. And I hope you guys are enjoying these videos. I'm trying to do my best to give you as much information in a shortened time period as possible. So I appreciate you guys, and I'll see you on the flip side. Thanks for watching Burt's Basics.